In this video, we'll talk about some other potential uses for Taylor series beyond what we've discussed previously. The big one for me in terms of Taylor series is the idea of approximating integrals. The point being, I can integrate a Taylor series term by term, which means instead of integrating a function, I can integrate the polynomial that is part of the Taylor series instead and use that to get me an approximation to what this should be. So things like integral of e to the minus x squared. This is not something we have an actual expression for. So if we want to do definite integrals, say from 0 to 1, we don't have a way to do this. We could do this numerically, or you could do something with Taylor series. Or in particular, Taylor polynomials, which are the cutoff versions of these series. These give us ways to actually determine what this number should be without needing to resort to numerical techniques like before. Both options are valid, both options work, but you can use either one here to solve these out. The other use is with computing limits that would otherwise need L'Hopital's rule. So the main idea here is you can set up limit problems and limit problems that exist where it would require many iterations of L'Hopital to figure out what this converges to. With Taylor series, this process gets a lot easier. And we'll see how this works with an example. Look at the following limit. We have the limit as x goes to 0 of 1 plus x squared over 2 minus e to the x over 2x cubed. And we see right away if I plug in 0, I get 1 minus 1 is 0 over 0. So I can go into L'Hopital and go from there. But since I see this 2x cubed on the bottom, it's going to take me 3 iterations of this process to get to an actual answer here. What can I do instead? What I can do instead is look at this e to the x I have on top. And if I look at these first 3 terms here, those are the first 3 terms in the Taylor series for e to the x. So we know that e to the x equals the sum x to the n over n factorial, but this starts out as 1 plus x squared over 2 plus x cubed over 6 plus x to the 4th over 24, and so on. The way I'm going to write this to sort of make this more clear is this is the same thing as 1 plus x squared over 2 plus x cubed over 6 x to the 4th times stuff. And this stuff is a polynomial. It starts with 1 over 24 plus other terms. It's a polynomial, they all have degrees of x in them, at least 0, so we're fine there. Then what does this setup tell me? Well, this tells me then that 1 plus x squared over 2 minus e to the x, I'm going to subtract off and cancel these 3 terms. And so I'm going to start with a negative x cubed over 6 minus x to the 4th times stuff. Now let's put that into the limit above and see what we get. So we had limit x goes to 0 of our expression from before. So now I'm going to plug that expression that I had from before into this one here. So I get negative x cubed over 6 minus x to the 4th times stuff divided by 2x cubed. And now I can cancel an x cubed from the top and bottom because they both have x cubes in them. So I get the limit as x goes to 0 of negative 1/6 minus x times stuff divided by 2. And now I can send x to 0 for free, and the stuff term just all goes away. That's why I was okay leaving it as stuff in there, because I wasn't going to care what happened to it eventually anyway. So when x goes to 0, this just comes out to negative 1 over 12. So if you know the Maclaurin series for e to the x, it becomes really easy to find this limit because I can just plug that in, cancel the first terms that are there, and see what comes out of it. So that's the idea of other ways that Taylor series can be used. They can be used to approximate integrals, and they can be used to calculate limits that would otherwise require many iterations of L'Hopital to make sure you actually get the final answer. All those important things to keep in mind when you're trying to solve these sorts of problems, and the reasons why we care so much about Taylor series, when they converge, and how well they work, so we can use them in these sorts of situations.